Everyone. Today we're going to be starting Unit 7, Lesson 1. We're going to be talking about graphs of exponential functions. You have studied these in your previous classes, so we may move rather quickly. An exponential function is written as f of x equals a to the x, where a is greater than 0 and a can't equal 1. An example of an exponential function is provided for you here, and this would be the graph of 2 raised to the x power. So let's kind of just go back to when you were learning how to graph. We would probably do something like this in some of your previous classes. So I want you to get an idea of the plugging in effect here. So if I was going to set up my table, -2, -1, 0, 1, and 2, these are the values I'm plugging in. And I would have 2 to the -2, 2 to the -1, 2 to the 0, 2 to the first, and 2 squared. And our points, our y values would be 1/4, 1/2, right? Remember your exponent laws. 1, 2, and 4. If you were looking at this in a calculator, which some of you may do, that's okay, you would get decimals here. And that's fine. Okay, but I want you to kind of see what's happening here. When we raise something to a negative power, it's flipping it. And that's really important when we talk about some of the properties. If we were plotting these, you might kind of go over here, -1/4, 1/4, -1, I'm at 1/2, 0, 1, 1, 2. And we can see our graph kind of grows in what we call an exponential manner. So this is an example of a growth. And this occurs when our base or our a is greater than 1. Other possible equations: 3 to the x, 4 to the x, etc. Anything that has a base greater than 1 there. In the next example, okay, obviously, this is an example of decay. And decay happens when our base is a number in between 0 and 1. Okay. This particular example is y equals 1/2 raised to the x power. And again, for this example, we're not going to graph this way always, but for this example, let's just set up a table. 1/2 raised to the x, and then our y value, just to see remember how the functions work. I would take -2, -1, 0, 1, and 2, and we're plugging them into, right? Plugging them in for x. Sorry, I put in the wrong base. Okay, so when we evaluate 1/2 to the -2, remember, this is really, we're going to flip the base. This is really 2 squared. So our y value is 4. 1/2 to the -1, we're going to flip the base 2 to the first. Our y value is 2. 1/2 to the 0, anything to the 0 power is always 1. 1/2 to the first is 1/2, and 1/2 to the squared is 1/4. Again, if you were looking at your calculator, which I know some of you are relying on, those would be your fractions. Okay, so let's just make sure our table works. -2 is 4, -1 is 2, 0 is 1, 1 is 1/2, 1/4, etc. And notice if we were going to connect our curve, we've got this decay pattern. Other possible examples would be 1/3 to the x, 1/4 to the x, etc. Okay. All right. So some basic properties. Okay. Just things that the characteristics of an exponential functions. When we're talking about exponential functions, you'll notice the domain is the set of real numbers. I can plug in any number. So our domain is the set of all real numbers. The range, however, when you're looking at the graph, the range, this number will, think about it. If you do 2 cubed, I'm sorry, 2 to the negative third, you're going to have 1/8. 2 to the negative fourth, you're going to have 1/16. That number, as we plug in more negative numbers, our answers are just going to get smaller and smaller and smaller. Okay. We're never going to cross the x-axis. We're just going to kind of ease it, get closer and closer and closer to it. So our range is the set of y values such that y is greater than 0. Our x-intercepts, we're not going to have any. And this is when we're talking about our exponential function in its most basic form. I should have said that in the beginning. Our y-intercept is always going to be 0, 1. Why is that? Because anything raised to the 0 power is 1. Our horizontal asymptote is going to be connected with the range. Our horizontal asymptote is going to be y equals 0. And our function is always going to contain the point 0, 1, which is the y-intercept, and 1a, whatever the base is. Because whenever we raise a number to the first power, we get that number. A number to the first power, we get that number. Okay. So we're going to kind of use these basic properties, and we're going to talk about other ways we can study exponential functions. So just like we can make transformations to other functions, we can make changes to the basic equation of an exponential. By now, you should be able to connect the concepts we've learned in previous courses and apply it to the exponential function. Specifically, we're going to be looking at how these transformations may affect the domain, range, and the horizontal asymptote. So let's take a look now. And let's kind of see if we know what's going to happen. So if I have the graph of y equals negative 2x, okay, what do we think is going to happen? Okay, I'm negating, think about this. I'm negating the function, right? I'm negating the answer I get. So I should see the graph, if I negate f of x, I should see the graph flip over x. Well, let's check that out and let's see if it happens. Oh, what should I use? I'll use Desmos. So I'm going to graph 2. I can't use this. We've got to use this one. Sorry. Clear. So I'm going to graph 2 raised to the x. I'm going to take a look at that picture. And then I'm going to graph negative 2 to the x. And we're going to see if it does what we said it would do. And we're going to graph that one. And yeah, we said it should flip over the x-axis, and that's exactly what it did. So there's my original. And there's my flipped. If we're talking about 2 to the negative x, when we negate x, this flips or reflects over the y-axis. So we should see our graph, if we have our basic exponential, we should see it flip this way. I'm going to go back into my calculator. I'll clear out what was there. And now I'm going to do 2 raised to the negative x. And hopefully we'll see it flip over the y-axis. And there it did. The blue is the exponential and the black is the flipped one. Again, this is my original. And this is my flipped. And in our last example, let's try to do this one first. There's my original. What do you think it's going to do? If you remember correctly, f of x plus or minus c is going to be a vertical shift. So we're going to take this graph and shift it up 2 units. And it should look something like that. Again, these are very general sketches. Plus 2. I'm going to shift it up. And there's my original, and there's my shifted. Okay. So for the next couple of examples, okay, what we're going to do here is we're going to see if we can just be a little bit more concrete about it on the graph paper. So we're going to start with our original function, 0, 1, 1, 2. Just like we did back in the transformation unit. There's my parent function. There's my original. So I have my 2 to the x minus 1. So I'm going to take the original function and I'm going to shift it down 1 unit, right? This means shift down 1 unit. So I'm going to take the points, shift them down. Ooh, should have been a little more careful there. It's also going to shift my horizontal asymptote. So now my graph is not going to settle at 0. My graph is going to settle 1 unit down. And that's going to affect our range. So if I'm describing the domain, the range, and the horizontal asymptote of this new function, my domain is still all reals. My range now is y greater than -1. And my horizontal asymptote shifted to y equals -1. I'm sorry, I should have pointed that out a little bit better in the original. We'll do it with this example. So if I have y equals 2 to the x plus 1, and we didn't talk about this, but again, I'm expecting you kind of remember some stuff. Now, where is the shift? The shift is attached to the x. Remember, when our shift is attached to the x, we shift left and right. And we always move opposite. So in this particular example, we're going to take our graph and we're going to shift it left 1 unit. I'm going to go back and make my regular exponential, 2 to the x. And now I'm going to take this, and remember your horizontal asymptote is y equals 0. And I'm shifting this graph 1 unit to the left. So I'm going to move this point here and this point here. And this is y equals 2 to the x plus 1. Now notice with the horizontal, did we change that horizontal shift? Did it affect the horizontal asymptote at all? No. So when we're talking about the basic properties, nothing's going to really change. So you might want to make a little mental note here. Vertical shifts. And if you think about it, reflecting over the x-axis. Will affect the range and the horizontal asymptotes. But anything done horizontally is not going to matter. So if we flip it this way, or if we flip it this way, it's not going to really make a difference. Before I move on, I just want to go back and mention one more thing. Let's look at this guy in the middle here. Did anyone notice something happening there? This is 2 to the x, and this is 2 to the negative x. And if you look at it, it's the perfect example of what happened here and here. So another way, another possible way we could see a decay function is with a negative power. Because really, what is this? If we think about our exponent laws, this is 2 to the -1 raised to the x power, which is really 1/2 to the x. Okay, So a lot of times when we get to pre-calculus, we're going to kind of see things written that way instead. Okay. That's just something we'll mention as we move through the unit. Okay. So that was a little review about stuff you should already know. This year, when we study the graph of exponential functions, we're going to really start to focus on what we call using base E. And base E occurs so frequently in math application, it is known as the exponential function. So something can be an exponential function, but when we say like, ooh, the exponential function, we're talking about f of x equals e to the x. And I want to remind you, because you have seen E before, E is an irrational number, non-terminating, non-repeating. It's 2.718, and it just goes on and on and on forever. Okay. Now, there is a special math derivation for E. And that math derivation is, if you were to, I'm not going to ask you to do it, but if we were to kind of fill in a table as n goes to infinity, so let's say I plugged into this expression here. Now, I don't know how mathematicians came up with that expression, but if we were to plug into that expression, you would see, if you kept getting bigger and bigger and bigger, you would see your numbers would get closer and closer and closer to 2.718. Okay. If you want to try it on your own, if you want to see the numbers you get and play around with it, you can. But this is how this number came about. So like we can just say that E is to exponents as pi is to circles, right? Pi is 3.14, and we use a symbol to represent it. E is 2.1718. We use a symbol to represent it, okay? So that's how we, learn to study E. Now let's actually practice graphing E. So I'm going to try to do this without the use of a calculator. Okay. And again, if you need to, you can plug it in to see how the numbers match up. But let's just think about this. If we want to plug in some numbers and get these values, we would have e to the -2, e to the -1, e to the 0, e to the 1, and e squared. Well, e to the -2 is really 1 over e squared, which is about, now just think about it, because we're graphing on this little xy axis over here. We don't have to be that exact. So if I'm plugging in 2.718, that's about 3 for e. So 1 over e squared is about 1/9. 1 over e is about 1/3. E to the 0 is 1. E to the 1 is e, which is about 2.718. Okay, and again, in calculus, you're going to have to learn to leave your answers in terms of e. So it's good to kind of know this. And then e squared would be about 9. We're not even going to fit that on the graph, so we don't even care. Now, if I'm plugging in, I want to put my 2 main points on. 0, 1, right, when I go to graph this, and 1 e. So e is about 2.718, so I'm going to kind of go right there. And really, the rest of the graph is just going to stay the same shape as an exponential. And that's all I really want you to be able to do, to visualize the shape of this curve. Just like every other exponential function, our domain is all reals. Our range is greater than 0. Our horizontal asymptote is y equals 0, which shows up right there, right? We could see it levels off at 0. And our points, 0, 1, and 1e. So it really fits with all the other functions we studied. So we're not going to be nitpicky. We're going to put our 2 big points there. Now, if I was to ask you to do some other transformations with this function, now we can start with our basic E curve and do these transformations. Oh, I should have made this a little bigger, sorry. We'll do our E in the blue. So our E is 0, 1, 2.7. Here's my exponential. That's my basic curve. What does this transformation tell me to do? I'm negating the function, negating e to the x, flip over the x-axis. So I'm going to take my curve and I'm just going to move it and reflect it. So my curve will go down like that. The domain is always all reals. That's never going to change. But this time the range, y is less than 0. And the horizontal asymptote, it was just a simple reflection. So the horizontal asymptote stays the same. And notice the connection between the range and the horizontal asymptote. Y equals e to the x minus 2. So I'm going to take my basic exponential and do what with it? This is going to be a horizontal shift right. 2. Basic exponential. I'm going to take my 2 important points and shift them to the right 2 units. Notice again with the horizontal shift, we're not changing anything. We still have 0 as our horizontal asymptote. So I'm just going to kind of level off and then go up. If I needed to describe the basic properties, I would have a domain is always all reals. My range did not change because I just did a horizontal shift, and my horizontal asymptote remains y equals 0. Now I've got 2 things going on here. I'm shifting left 3 units, and then I'm going to reflect over the x-axis. Shifting left 3 units and then reflecting over the x-axis. Start with your basic curve. Shift left 3, 1, 2, 3, 1, 2, 3. Reflect over the x-axis. And there's my new curve. Domain never changes. The range now just reflected over the x-axis. We didn't do any vertical movement. So my range did not change. I'm sorry, yes, my range changed it because we reflected, but my horizontal asymptote did not. One last example before we leave for the day. Ooh, now I've got a piecewise. Piecewise is a bit of a challenge. The piecewise is a tiny bit of a challenge. So let's see what we would do here. I might kind of work with tables, right? E to the x if x is less than 0, and e to the negative x if x is greater than 0. So if x is less than 0, I'm at -1. We're going to plug 0 in to see what happens. E to the -1 is 1 over e. E to the 0 is 1. -1, 1 over e again is like 1/3. So I'm going to be there and there. When x is greater than or equal to 0, I start at 0 and I'll use 1. E to the 0, e to the -1. Oh, this is a weird picture, huh? But let's think about this. My graph is e to the x when x is less than 0. So I'm going to do this portion of the graph. And I'm e to the negative x when x is greater than 0. So I'm only seeing this portion of the graph. So my horizontal asymptote is y equals 0. And when I make this picture, it's just going to kind of go like that. Okay, a little bit of a challenge, but I just kind of wanted to review some things and talk a little bit about stuff. The domain here, the domain, we're all real numbers based on our function. My range, now I'm going to go right from my graph because that's going to be the easiest way to deal with this. Y is less than or equal to 1. Oh, no. Because I've got that horizontal asymptote. 0 is less than, y is less than or equal to 1. And my horizontal asymptote is y equals 0. Okay. So just a little review, right? We added exponential, learning how to deal with it. And then we reviewed our transformation laws with the exponential function and ended with a nice, fun little piecewise. Okay. So do your homework questions and we'll be back again tomorrow. Thank you.